Hey, all you happy lost souls. How are y'all doing out there? We're going to do a little video about more tips and tricks when you're actually out in the field to help identify areas with gemstones um, of different varieties. In my area, we have a ton of metamorphic rock, metamorphic zones where there's a ton of plate tectonics, volcanic activity in the past. Um, Honestly, a couple of the areas through Huntington Valley, Wissahickon Valley, those areas were actually formed by the remnants of an ancient dying continent, one that broke off from Mars. Um, so all of these metamorphic processes and different induction zones of heat and pressure create all of these gems. And it's created out of something called alluvium mud or clay. And what that is, it's all of the clay and sediment and sedimentary rock that was broken down. It becomes a mud and a clay, and it gets pressed and squeezed and heated, and it becomes schist after a while. And this brings us to our next topic. You see some of the garnets in there. Parent and sister rock. A parent rock is the rock that it was before the metamorphic process occurred. Like, what materials were geologically changed to become this other material, essentially? So we already told you that sediment, mud and clay, in really, really rich aluminum rich clays heated up to the right temperature over 650 degrees. In that range is the melting point for aluminum. And then its exposure to oxygen or water and the rate at which it cools and the rate at which contaminant trace metals are found in association in that clay, you'll get corundum if it's aluminum. It's not the only gemstone that obviously forms. Most of your gemstones are going to form in metamorphic rock. They'll be found within the metamorphic rock. They'll be found within the alluvial deposits in streams, the gravel bars, the big beaches of alluvial sand and stone. And you can find all kinds of things in in these gravel pits and these deposits along creeks, especially when they're near geological upticks that are metamorphic. And the parent rock is a thing to really learn. So, you had sedimentary rock first, which is sandstone, not sandstone, but siltstone, mudstone, shale. So the parent rock is shale. Shale gets heated and pressurized, and it changes into schist. And in some rare cases, you get pieces like this. And I found entire wooden handles from old tools that have been petrified and silicated in the schist, which a really unique process has to happen. It's not frequent, but it is extremely possible. What would happen is wood or branches or any part of organic wood gets, a branch even, let's say, gets trapped under that mud where there's no oxygen that can get to it to rot. And that mud is alluvium and rich with aluminum and silicate. And there's a lot of silicate in that mud. And no oxygen exposes the wood during that process of metamorphosizing or metamorphification. That doesn't even sound right. But as it metamorphosizes and the shale becomes the schist, if there's any wood submerged in those muddy alluvium deposits in the right conditions with no oxygen getting to the organic material, you get silication or silicated or petrification. And you can kind of even see some of the grains in the actual wood. And oddly enough, it's almost shaped like a handle, but who knows. Be careful with this stuff though, because remember, it was sedimentary in its original form as shale. So these lines could also just be the layers that you're still seeing from when it was sedimentary rock. And you get that banding all throughout rock, because what happens when this gets pressurized and squeezed and heated even more, it's the parent rock to granite. And you can go right up the lines. You know, granite gets squeezed and pushed into gabbro. Gabbro gets squeezed and pushed into gneiss. These are all metamorphic rocks, and within all of these rocks you can find gemstones. So if you find a lot of the sister or parent rock in the area, good chances are your target specimen will be there. For instance, a sister rock to corundum. These are all aluminum oxide examples of corundum. Some of the tools, some of the pendants are made out of it. Anyways, there's stuff that forms in association or near these aluminum oxide areas, or areas where you'll find garnets and aluminum oxides. What you'll find in the area, and I have two examples here besides just the schist, there are really three examples of sister rocks. So here is some, first you got biotite mica, and then it's got some muscovite mica in there too. These are all sister, brother, whatever, cousin rocks, were found in association with sapphires. Another one, which is going to be a tongue twister, is nepheline syenite, which is this speckled orangey brown looking rock. It's kind of got like a bluish tint, almost looks like corundum a bit in how it forms in that formation. It's pretty hard too, so it could fool you with a hardness detector. And what nepheline syenite is, it's a naturally occurring igneous rock, and it's composed of nepheline, albite, and a microcline. So it's got an extremely high aluminum content. And why is that important? Because the gemstones in my area are aluminum oxide. So you need a whole lot of aluminum and the right geological pressures, situations, and conditions over time to form these sapphires. Another really good way to tell like a sapphire is, a lot of times they'll have a band, like a blue gem band running. So this is like layers of yellow and blue. And when yellow and blue get layered, you know, they form green. If that was a tighter formation or tighter banding in the color zoning there, you would get a more green appearance. You kind of get that down here with this massive sapphire. I got a smaller version of the same exact stone right here. These two are like the same color. But this will be considered green sapphire. I know it doesn't look very green, but it is a combination of yellow and blue tightly banded. And in this one, you can see the banding running through it. And it grows in that sheet. And you can see, here's another telltale sign. When a sapphire forms, oftentimes, because it's growing in the schist, it'll have some schist along the edges of its facets, or the edge of the surface of the stone. This should never penetrate within the actual sapphire. And this is because aluminum oxide, when it's forming, does not mix with silicates. It'll start forming, and when it hits silicates, it'll stop the growth process essentially, or it'll shape it differently. But a lot of times what you'll get is these surface inclusions of biotite mica or schist on the outside. I polished it off the rest of the sapphire here, and I left that on just to show you guys how that can form. Like this one here, this was absolutely covered in mica. Only a little bit of the top was exposed, and I'm like, oh, there's a gem in there. So I started using my little hand tools and Dremels and got all that schist off. And like this one was literally white like milk with blue lines in it when I found it. And I polished all the biotite, all the mica that was on the surface off, and it got extremely transparent. I mean, some of these are absolutely, first they'll get under the black light. You'll see they'll get, they're black light sensitive. But other than that, you can see right into this rock, and you see all the banding now, and you can kind of see the green with the yellow and blue striping throughout the rock. We got another one here. And the beautiful thing about this is it's very faceted naturally. You can see, you can see all the natural facets in there. Let's see, 1, 2, 3, 4, 5, almost 6. Self-terminate it. The rest of the matrix. So that's a really good tip for helping locate where you could possibly find different gems. And other gems that can grow in metamorphic rock are endless. Topaz, if there are kimberlite or old volcanic pipes within the metamorphic zones, you can find diamond, all kinds of garnets, topazes, all kinds of sapphires, rubies, all kinds of different quartzites and agates. And God only knows what other rare type of stone you can come across. Like, I have this stone here, which reads about 8. It's not quite as hard, but this dark reddish brown color, and its formation looks a lot like painite, which is one of the rarest gems ever found, but they apparently only grow in Myanmar. But maybe they just haven't been discovered anywhere else, or they were mistaken for something else. There's so many rare minerals out there. So really got to use where you found it, the color, the shape, the hardness to help identify. Another great tip is to look at all the geological surveys of your area and know what you're dealing with as like a base substrate. Are you in an igneous zone? Are you in a zone that's mainly just silt, mud rock, and sedimentary type rock where you're not going to find very many gemstones? Or are you in a metamorphic area? Or are you in an area that has a lot of limestone and quartz? My area is unique because half of the uptick is all metamorphic. And then once I'm in Willow Grove, once it comes towards my way and heads even more towards, I guess you would say it's more towards north west, you would get into that crazy limestone. And we got Limekiln Pike. It runs right through the neighborhood. The limestone was used, crushed up, heated to make mortar, and cement, all kinds of other stuff. But within limestone, where it meets quartz, as the water runs through, the water strips away the limestone. It's softer than the quartz, and it deposits gold within the veins and seams of the quartz. So if you got a lot of quartz and a lot of limestone in one area, you're most likely going to be able to find some golds. The area where I find a lot of this stuff also has a lot of old mines, even back from colonial times. There's the rumor of the silver mine, but there is also a known lead and mercury mine right in the vicinity of these upticks. And if you look at a periodic table, lead and mercury are right next to silver and gold. So it means they're found next to one another in nature, essentially. But yes, this is a very important clue, though. This and this. If you got a lot of these two materials, nepheline cyanite, and muscovite, and there's actually biotite on the back, a lot of biotite. But this stuff here is super soft. So like biotite almost feels like Scotch tape. It'll peel off in layers. I'll show you real quick. I'll pop out the hardness reader. I haven't done that in a while. And I have a whole video on how to use these guys. I have several of them. I bought a couple of the same kind just to test them against each other. But how we use this is first we have to turn it on. And when we turn it on, we want to start it up at about one or two. It's fine. One's fine. And we're just going to like let it sit here until it gathers the temperature of the room and that second light goes on. Once the second light goes on, it's ready to use. There we go. Just popped on. Now usually in a big room and I'm testing bigger stones, I'll put it up to about a 2.5, 3. And what I'll do is I'll first take a base reading, and since there's a mirror right here, I can take a base reading on this, and you can see glass is coming in right around 5 to 6, which is where it should come in at. And we also know what biotite and muscovite schist should come in at. They should come in almost lower than glass. You want to make sure your fingers are on the back of this sensor too. These things work by sending heat out through a little probe. So the biotin is coming in at about a 4.5 and 5. It's 1 under the glass. So that that all checks out. But watch what happens when you get onto a sapphire real quick. That's how hard a sapphire is in comparison to your schist. Your schist is nice and soft, and then you go over to the sapphire and you're going to get 9 or higher on the Mohs scale. Same thing, we come over to a yellow sapphire here. The color changes, but the hardness is not going to change. And I'm going to come over to some here's a pale blue sapphire. Oh, same deal. Here's a pad paradasha, one of the rarest colors, a combination of pink and orange. Got 2 of them. They're in pretty good shape here. Bingo, bango. Bingo, bango. But just so... And then this is the stuff I can't really... I thought it was painite. But let's see what it comes in at. This could be some type of feldspar. This is coming in pretty hard. I'm going to lower this a little bit because it keeps raising itself up from the base reading. You want to be careful when you use these two that you do not get the probe, the tip of this thing right here. You don't want to get that down into a crevice or a pit in the rock because it'll just read max hardness. So this one coming in around a 7. 7.5, 8 on this red stone here. So that's going to be some kind of feldspar most likely. And it does kind of have that feldspar look, but it's very pretty. It's even got like a gold, maybe a gold inclusion in it right there. You see that? It's pretty crazy. And like I said, within the schist, the other gemstone that you'll find a lot of is this garnet. I've shown this many times, but you see those little black, beautiful little dark black reddish pieces of garnet within the schist. And this is a Wissahickon garnet schist complex. We got the snapping turtle head right here. So a Native American or even older human from way, way back, thousands of years ago, carved an effigy of a snapping turtle out of yellow corundum with red color zoning. And we'll just test it to see how hard it really is. Oh, bingo bango, right on sapphire. We got some rough blue. I'm actually going to be cutting this soon, testing my new saw out. Bingo. Then you have things like this. that are real crystallized. This is some. Hey y'all, I'm sorry about that. My camera was really acting up. But I just want to end the video. Pretty much went over all the little tips and tricks for this video, and I want to say thank you. Please subscribe, and I love you all. Stay safe, stay happy, and if you're lost, find yourself. Anyways, please subscribe. I hope you like the information on gemstones and the clues as to where to find them and the things that are associated with them, to help you narrow in your search. So happy hunting to all you rock hounds out there, and check out the rest of the channel. I love you all. Please subscribe. Stay safe. Peace.